Hello friends. Today we shall start with this yet another transform which is called as the Z transform. Topic of difference equations is over, almost over. Now we are switching on to this next part of this fourth unit which is called as the Z transform. So let us precisely define what is the definition of this Z transform. Let f of k be the discrete sequence for k greater than or equal to 0, then Z transform of f of k is denoted by f of z is equal to summation k equal to 0 to infinity f of k into z raised to power minus k. This is not an integral transform. It is the discrete transform. It is obtained by taking the infinite sum, summation 0 equal to infinity of that discrete sequence f of k multiplied by z raised to power minus k. If this infinite sum converges to some z, fixed z, f of z, then and then that f of k has the z transform f of z. Otherwise, z transform does not exist. So, this is the basic fundamental definition of z transform. So, z transform of some elementary sequences note should be noted 1 plus x plus x square plus x cube, this infinite sum is equal to 1 upon 1 minus x, provided that mod of x is less than 1. This you know very well. Many times we have used this relation. This is geometric progression. 1 plus r square r cube. Infinite sum is 1 upon 1 minus r, provided this common ratio is of the geometric sequence must be less than 1. So we would be using this result frequently in this. So obtain example number 1. Example A. Obtain Z transform of a raised to power k, Z transform of 1 or 1 raised to power k, Z transform of sine of ak, Z transform of sin h of ak, Z transform of cos of AK and Z transform of cos H of AK. This 6 elementary, this sequence is a raised to power k means a raised to power 0, a square, a cube and so on. 1 raised to power k, 1 raised to power 0, 1 raised to power 1, 1 raised to 1 square, 1 cube and so on. This is constant discrete signal sequence. Sin ak means sin 0, 0, sin 1k, sorry, sin 1a, sin 2a, sin 3a, k equal to 0, 1, 2, 3. So let us determine the first Z transform of a raised to power k. By definition, this is equal to summation k equal to 0 to infinity f of k into z raised to power minus k. That is further equal to summation k equal to 0 to infinity f of k is a raised to power k into z raised to power minus k. Or this is further equal to summation k equal to 0 to infinity a by z raised to power k. K varies from 0 to infinity, so it is equal to 1 plus a by z plus square of a by z plus cube of a by z plus and so on, and from this formula, this is equal to 1 upon 1 minus a by z, provided that mod of a by z should be strictly less than 1. So Z transform of a raised to power k, thus Z transform of a raised to power k is equal to Z upon Z minus a. If we multiply numerator and denominator by z, we get this. Provided that this a by z should be less than 1, that means mod of z should be greater than mod of a. Note this. The first formula for the z transform of a to the power k. In view of this, what would be, therefore, z transform of 2 raised to power k would be equal to z upon z minus 2. Mod of z must be greater than 2. Z transform of 1 by 2 raised to power k would be equal to z upon z minus 1 by 2. So that is equal to 2z upon 2z minus 1 mod of z should be greater than, or 2z is greater than 1. So we can determine the z transform of such similar discrete sequence of the type a raised to power k sequences. So note this first formula. Now second, z transform of 1 raised to power k. One raised to power k. Since
Z transform of a raised to power k is equal to z upon z minus a mod of z is greater than 1. From this formula, if I put a is equal to 1, if a is equal to 1, therefore z transform of 1 raised to power k is equal to z upon z minus 1 mod of z. It should be a here. Should be greater than 1. So, again note this second formula. Z transform of 1 raised to power k is z upon z minus 1. Sine of ak.
Discrete sinusoidal signals, Z transform of sine of AK, that is equal to
Z transform of.
Now what is the exponential formula for sine of AK? It is 1 upon twice I times
e raised to power I ak minus e raised to power minus I a. That is further equal to 1 upon twice I times, that is constant, independent of k, z transform of e raised to power I a raised to power k minus z transform of e raised to power minus I a of k.
just I have written sine of AK in terms of exponential formula number 1, and here now I would be using the formula for Z transform of A to the power K. First formula Z transform of A to the power K is Z upon Z minus A.
So here it is equal to 1 upon twice I times. This is z upon z minus e to the power I a minus z upon z minus e to the power minus I a. That is further equal to z upon twice I times 1 upon z minus e to the power I a minus 1 upon z minus e to the power minus I a. Z upon twice I. Simplify this. Cross multiply and subtract 1 into z minus e to the power minus I a is z minus e to the minus times 1 into this. 1 into z is z. Minus minus plus z raised to power I a upon z minus e to the power I a into z minus e to the power minus I a. This z goes e to the power I a minus e to the power minus I a. It is 2 cos a z into 2 goes, let me write 2 cos a upon twice I, no, see here, z upon e to the power ia minus e to the power minus ia upon twice I. It is sine of A. Z into sine of A upon this. Let us multiply this. Z into Z is Z square minus Z into e to the power IA plus e to the power minus IA plus e to the power IA into e to the power minus I. So it is equal to Z sin A upon Z square minus twice Z. This is cos of A plus 1. That is the Z transform of sin of KA.
Sin of Ka is Z sin A upon Z square. This is 2 cos A into Z. So 2Z cos A plus 1. Note this third formula. Z transform of sin of Ka is Z sin A upon Z square minus twice Z cos A plus 1. Now, Z transform of cos of A. Fourth formula. Now, cos of AK is 1 by 2 times e to the power IAK plus e to the power minus IAK. 1 by 2 times Z transform of e raised to power IA raised to power K plus e raised to power. So it is 1 by 2 times. These are the transforms. Let us rewrite this or recalculate this. This is Z by 2.
One upon Z minus e to the power IA plus 1 upon Z minus e to the power minus IA. So it is equal to Z by 2 times Z minus e to the power minus IA plus Z minus e to the power plus IA upon Z minus e to the power IA into Z minus e to the power minus IA. So, it is Z by 2 times Z plus Z is 2Z minus e to the power IA plus e to the power minus IA. Denominator is same here, so it is Z square minus twice Z cos A plus 1
As in case of the
previous example. So it is equal to Z by 2 times 2Z minus 2 cos A upon Z square minus twice Z cos of A plus 1. So it is equal to 2 goes here. So Z into Z minus cos A upon Z square minus twice Z cos A plus 1. That is Z transform of cos of AK. Note this fourth formula.
For sin AK is Z sin A upon this. Z times sin A upon this. So, Z transform of sin of AK is equal to Z into sin A upon the same denominator Z square minus twice Z cos of A plus 1. Similarly, fifth, sin h of AK and cos h of AK.
Z transform of sin h of AK. Sin h of AK means Z transform of 1 by 2 times e raised to power AK minus e raised to power minus AK. So it is equal to 1 by 2 times Z transform of e raised to power A raised to power K minus Z raised to power Z transform of e raised to power minus A raised to power K.
Same logic I have used here.
1 by 2 times
Z transform of e to the power k.
Z upon Z minus e to the power A minus Z upon Z minus e to the power minus A. So it is equal to Z by 2 times. I am simplifying this directly. Z minus e to the power minus A minus Z plus e to the power A upon Z square minus Z into e to the power A plus e to the power minus A plus 1. So it is equal to Z by 2 times e to the power A minus e to the power minus A is 2 sin h of A upon Z square minus 2Z, this is cos h of A, 2 cos h of A plus 1.
So Z transform of sin of AK is Z sin A upon Z square minus twice Z cos A plus 1. Whereas
Z transform of sin h of A, sin h of AK of course, is equal to Z sin h of A upon Z square minus twice Z cos h of A plus 1.
sin is replaced by sin h and cos is replaced by cos h. Otherwise, transforms they are same. Note this. Similarly, this is the sixth transform. Z transform of cos h of AK would be equal to Z into Z minus cos h of A divided by same denominator Z square minus 2Z cos h of A plus 1. Sin h of AK, cos h of AK, this is sin of AK, cos of AK. So these are the 6 transforms. First we have learned Z transform of A to the power K, Z upon Z minus A, number 1. Second was Z transform of 1 raised to power K, Z upon Z minus 1. Then sin of AK, third. This is this cos of AK, sin h of AK and cos h of AK. You need to remember this 6 standard or elementary Z transform. In the next lecture, we shall study some basic properties of Z transform, and then again we shall solve some more varieties of examples based on this Z transform. Thank you very much. Thank you.